Welcome to this video on logarithmic functions part 2. In the first video, we converted between logarithms and exponents. In this video, we will learn how to evaluate logarithms, and we'll also use the ability to convert between logarithms and exponents in order to solve basic logarithmic equations. Let's begin. So one way to evaluate logarithmic expressions without the use of technology is by rewriting them in exponential form. So let's practice doing that. So remember, this number down here is our base. So when we write this in exponential form, 2 is going to become our base. Then what is 64? Well, 64 is the result. So 64, if you recall, goes on the other side of the equal sign. Well, what are we missing here? We're actually missing something, right? It should say log base 2 of 64 equals x. So if you recall, this is our exponent. So in other words, what we're asking is 2 raised to the what power is equal to 64. Now, as you can see below, I've already generated a nice little number line for us, and we can use this number line, we can turn it into a log scale, and then we can evaluate. So 2 to the 0 is 1, 2, 4 again. The pattern is that we're just multiplying by 2 every single time. So the question is, how many times do I have to multiply 1 by 2 before I get to 64? Well, once gets me to 2, twice gets me to 4, 3 times gets me to 8, 4 times gets me to 16, 5 times gives me to 32, and last but not least, 6 times gets me to 64. So in other words, this scale is telling me that 2 to the 6th power is 64. So I can erase this x on the other side of log base 2 of 64, and I can say that the log base 2 of 64 is 6. In other words, I have to multiply 2 by itself 6 times in order to get to 64. Let's do another example. This time we have a base of 125, don't we? Whoa, well that's kind of crazy, right? 125 to the 0 power is 1, 125 to the first power is 2, 125 to the second power, well, I don't even know what that is, right? So this is asking us, let's rewrite it in exponential form. So we have log base 125 of 5 is equal to x, okay? So that means that 125 to the somethingth power is equal to 5. Well, notice that where I'm trying to get is smaller than, right? I'm trying to get to 5, right? So that means, and 125 is much larger than 5. So that means x is probably going to be a fraction, right? This is probably going to be smaller than 1. Does this remind you of anything? Well, it should remind you of something that we did in the last section, right? We learned to rewrite when we have problems like this. We learned to rewrite numbers like 125 and 5 as having the same base. So how can I rewrite 125 with a base of 5? So even though 125 is the base, right, it still is, I want to play around with 5 as a base and get a little bit of information here. So 5 to the 0 is 1, 5, 25, 125. Well, that's interesting, right? 125 is 5 to the 3rd power. So what happens if instead of 125, what if I rewrite this as 5 to the 3rd power raised to the x equals 5? Again, hopefully this feels familiar. We just did this in the last section. Then we can use the power rule, right? So we have 5 to the 3rd power raised to the x power. The power rule tells us to multiply the 3 and the x. So we have 5 to the 3x is equal to 5, or 5 to the 3x power equals 5 to the 1st power. And again, in the last section, we learned what we can do since the bases are the same and the whole expressions are the same. Therefore, it follows that the exponents must be equivalent. So we can solve for x, and we find out that x is equal to 1/3. So that would be our final answer. So in other words, the log base 125 of 5 is equal to 1/3. All right, let's do another example. This time we have the log base 3 of 1/27. So here my base is 3. So I'm going to have 3 to the something power equals 1/27. Okay, and we can just use x to hold the place of our exponent. So let's go ahead and fill in our scale down here. Okay, so the fact that I have a number that is smaller than 1 tells me that I'm probably going to have to go left from 1 and not right? Because if I go this way, you can see that my numbers are getting larger and I need them to get smaller. So this is 1/3, this is 1/9, this is 1/27. So I found my answer. So I can rewrite 3 to the x equals 3 to the -3rd power. That means that x is equal to -3. Objective 3, solving logarithmic equations. Solve for x by rewriting the logarithmic equation in exponential form. So let's begin. If we look at number 1, we can see that the base is x. Okay, then we can see that the exponent on the other side of the equation is 2. So we have x squared is equal to, oops, sorry, not 79. X squared is equal to 49, okay? So how do we solve this equation? X squared equals 49. Can I just take the square root of both sides? And I find out that x is equal to 7, okay? Now you might be remembering that when you take the square root of a number, you can get a positive or a negative result. But remember, x always has to be positive. So we're always going to go with a positive solution, okay? Let's do the next one. Again, x is our base, 4 is our exponent, so we have some number raised to the 4th power is 81. Well, how do we solve that? Well, we just take the 4th root of both sides, and we get x is equal to 3. Again, you might be thinking, hey, x is actually equal to plus or minus 3, but remember when we introduce logs, we have the restriction that x has to be greater than 0, so the only solution is positive 3, not negative 3. All right, let's keep going. So this time we have x to the -2nd power is equal to 1/9. So this is a little bit tricky because I can't, as far as I know, take the -2nd power, this -2nd root, right, of this. So we have to be a little bit tricky. How can we do this? Well, what could we do? Well, we could also say that this is, we could leave x to the -2 here, right? But isn't 9 equal to 3 squared, right? And let's keep going, right? 1/3 squared is equal to 3 to the -2nd power. So we just figured out that x is equal to 3. So that's one way to think about it, okay? You could also go through and draw your log scale for base 3 if you needed to. All right, let's keep going. So we have the base of 10, so the base is 10. The exponent is 0, so we have 10 to the 0 power equals something. Well, you might remember anything to the 0 power, except for 0 itself, is equal to 1. So x is equal to 1. All right, let's keep going. So now we have 3 raised to the 2nd power is equal to 2x plus 1. Well, 3 squared is equal to 9, so we have 9 equals 2x plus 1. We can solve this by subtracting 1 from both sides and then dividing both sides by 2, and we find out that x is equal to 4. Okay, it's often a good idea to test this if I put 4 back in here, because remember we can't have our argument be negative. So let's just make sure that this is going to work. So we have the log of 2x plus 1, so 2 times 4 is 8, 8 plus 1 is 9. So we have the log base 3 of 9 is 2, and sure enough that checks out because 3 squared is equal to 9. So that is our final answer. All right, let's do one more. We have 5 squared equals 3x minus 2. So we have 25 is 3x minus 2. We can add 2 to both sides of our equation. We get 27 is equal to 3x, oopsies, divided by 3, and we get x is equal to 9. Again, it's always good to double, triple check here. If I put 9 back in here, 3 times 9 is 27. 27 minus 2 is in fact 25, and so we would have the log base 5 of 25 equals 2, or 5 squared equals 25, which of course is a true statement. So x equals 9 is my final answer.